All right, today we are going to be starting our lesson number 4 for Unit 1, and I am going to be breaking this lesson up into 2 separate videos just so that we can kind of separate the concepts in case it takes more than one day. So today we are talking about translating expressions, and we will use these same translations when we start beginning working with equations and inequalities as well. So this one piece of paper is going to carry us very far this year, and we will need to learn how to properly show our annotations. Annotations is just a way of marking on our word problems or on our phrases that we see to help us turn those words into mathematical symbols. So that's what we're going to be doing today. So I am going to go ahead and put up here all of the words that mean addition. So here's my list. I have plus, add, sum, total, increased by, and more than. All of these words are words that would represent addition. Next, let's go ahead and make our list of subtraction words. I'm going to put here minus, difference of, decreased by, less than, and subtracted from. All right, so these are all of my subtraction words, and I did draw an arrow from my subtraction words down to these turnaround phrases. These turnaround phrases, while they do still mean subtraction, it means that the information around the subtraction sign should be turned around backwards, and we will see plenty of examples of that. Next, I'm going to go ahead and put up all my words that show multiplication and division. I have gone ahead and put my multiplication and my division words. My multiplication words, I have times, product, twice, double and triple, and then the word of. Of course, double and triple mean to times 2 or times 3. It's a specific number to multiply by. With division, I have half of. That is always going to be dividing by 2. A third of is dividing by 3. And then more basically, I have just divided by, and the quotient of is typically how you will see that. So quotient of. And finally, let's write down our parenthesis phrases. So whenever you see the word times, the sum of, so let me write this in a different color. Let's do purple. Times the sum of. Whatever words come after the sum of, those will go inside a parenthesis. Okay? The other way that you will see it will be times the difference of. The difference of, and those will go into parentheses. Those become really important because we'll have to do the distributive property in order to solve what that is. So if you need more time to copy this down, go ahead and pause the video. If you're ready to move on, let's go see some more examples of how we're going to use this. Okay, so it says translate each expression or equation. So I am going to be color coding just like I do in class. Okay, and I'm going to be annotating. So here's my annotations. Whenever I see something that tells me to add, subtract, multiply, or divide, I'm going to underline it. Okay, so in number 1, I see the product of a number. So here's my, whenever I see a number, that means it's some unknown variable. And 3. Well, 3 isn't going to change. It just stays 3. And so let's see how we can write that. There's 2 different ways to do it. You can write the product of a number times 3, Or a better way to write it would just be 3x, because if you remember from our previous lesson, the coefficient of a variable term needs to go in front of the variable. Okay? Let's look at number 2. The difference between a number x. If you wanted to use another variable here, you could. I just tend to stick with x. You're welcome to use n, op, any letters that you want, okay? And 10. So when it is just stating the difference of, it is just regular subtraction. It is not in our turnaround phrase category. So I will just simply do a number minus 10. And I know that the x comes first because when I read the problem, that was listed first in the words, okay? So when I read it first, then I have to translate it and write it first. Okay? I want you to pause this video and give number 3 and 4 a try. Be sure to show your annotations as well. All right, I want you to take a look at number 3 and see how you did with the quotient of a number and -5. There are 2 different ways of writing it, but both do say x divided by -5. The second way here is probably the most preferable for us, okay? If you'll notice, I did not complete number 4 all the way. So I was reading number 4, and it says 4 subtracted from a number. And if you look over, or up actually, at your turnaround phrases, you're going to see subtracted from as a part of our turnaround phrases. So here's what we're going to do to annotate a turnaround phrase. Whenever I see subtracted from, yes, it will be subtraction, but that subtraction sign will go, whoops, let me put that back. The subtraction sign will be moved to the fronts of the word that was in front of it, okay? So 4 subtracted from means I'm going to put that minus sign in front of the 4. And then the word a number means x, and that will go in front. So turnaround means that I take that 4 and I take that x, and how I read them, I'm going to write them algebraically in the reverse order. Turnaround words are some of the harder ones to translate. But I do need to see your arrows showing your turnaround words. If I don't see that, I know that you did not realize that that turnaround word was there, and that's going to lead to some mistakes. Okay, let's go look at number 5. We're starting to have more than just one number and one variable involved. Okay, so the sum, that's what's happening. So the sum of twice a number. So twice a number means 2 times a number. The way that I write that is 2x. So 2x and 7. So there's the 7, and there's how that will look. All right. Number 6, same thing going on. The product of a number, so my variables are in green, a number and 10. And then I noticed something here. I'm going to switch to orange or yellow, whatever you want to call this. I see a comma. Whenever you see a comma, that means some more information is about to come. Okay? It's going to come after the comma. That's true whether we're in math class or English class. So it is important to pay attention to the commas. It also means to pause. All right, so I'm going to translate the first part of this. I'm going to read it. I see the comma. I'm going to pause, and then I'm going to do the translation. So, the product of a number and 10, product means to multiply them. So I'm going to say x times 10, but I'm going to put my coefficient in the front. So 10x. Okay. Now that I've translated the first part of the sentence, I'm going to go back. And then I'm going to start at the comma, and I'm going to translate the next section. It says increased by. Increased by means plus. And then I have another number here, so increased by 1. So my final translation here is 10x plus 1. Okay, I would like for you to pause the video. Try to translate number 7 and 8. They are on the right side of your paper at the very top. Be sure that you also are practicing with your annotations. And then when you've completed them, unpause the video and I will show you my answers. All right, welcome back. I have completed numbers 7 and 8. Take a look at those. And I want you to see, were you able to identify the turnaround word in number 7? The phrase less than should tell you to reverse the order of the information that you were given with the minus sign left in the middle. Number 8, you could have written it 2x with a divided by sign 5 over there to the right, but the preferable way is with the division bar. Okay. Hopefully we're doing well with this. If you're ready, go ahead and move on to the next part with equations. If you're not quite ready, raise your hand and ask Ms. Brown any questions that you have. Okay, I'm going to go ahead and move on to page 3. And everything on this section of our notes is about equations. We're still translating the same way that we did examples 1 through 8. However, there is going to be a key word in every single one of these that is a new word that we did not see before. The word that we're going to see, and I'm going to try to highlight them, is, oh, it doesn't highlight, it just covers it up. Okay. Is the word is. Let me make this a little smaller. The word is in every one of these means equal or is equal to. All right, these are super important. Also, you might see is the same as down here in example 14, but it also still it has the word is. So is definitely means equals, all right? So I've done it in all of my examples. As soon as I have identified the equal sign, then I can go ahead and start translating the rest of it, all right? But we've at least got our equal signs all here. There we go, finished that up, okay? Now let's go back. The sum in number 9, the sum, so I'm going to have a plus sign here, of twice a number, so that means twice a number is 2 times x and 10. So all of that became, or all of that, I read it all before the word is, so it all is on the same side of the equal sign. And then I see is 36, so that 36 is over here by itself. All right, and that's my answer. We're not solving anything today. All we're doing is translating it, okay? taking it from a bunch of words and turning it into a mathematical equation with variables and numbers that we can work with. Let's take a look at number 10. 3 times, so 3 times, the difference of. So we're going to be doing subtraction here. All right, 3 times the difference of is actually, let me put this in parentheses. The difference of is one of those parenthesis phrases, okay? So it's going to be tricky. Like, we're going to want to be careful when we see those types of phrases, okay? And then the 3 times here is telling me to put a 3 in front of the parentheses. Okay, 3 times the difference of. Now I need to fill in what's going to go inside the parentheses. It says a number and 7. So 3 times the difference of a number and 7. There's no turnaround phrase here, so the X came first and the 7 came second. And finally it says is equal to 18 right there. So 18 goes on this side by itself. All right, hopefully this is starting to make some good sense to you. Really all that we've done is add the equal sign. That was our first example with a parenthesis phrase. But what I'd really like for you to do is try numbers 11 and 12 on your own. Pause the video, give it a try, all right? All right, take a look at numbers 11 and 12. Hopefully in number 12 you were able to identify that parenthesis phrase. Our parenthesis phrases are going to be the difference of. Remember, of means multiplication. So I really do have the number 5 times everything in that parenthesis, okay? And then the sum or the difference, those words tell you which operation is happening inside the parenthesis. Okay? If you're still uncertain, ask Miss Brown. I'll come over. I'll try to help explain it a little more for you. If you feel like you're doing good, let's just keep watching, okay? Because 13 is really where it starts to step up a little bit. In 13, I'm actually going to erase my equal sign because I think I'm going to need to move it over to here. Okay. All right. So in 13, I see 1/2 of means multiply that 1/2 by a number. Well, when I have a variable and a number, I don't have to put any symbol to represent multiplication. It just is sort of there. 1/2 of a number is, so my equal sign goes after that. 1/2 x equals. And then I have 8 less than, and this is sort of on 2 different lines, so it does make it tricky to show, but this is a turnaround word. So I will have subtraction here, but the number 8 will go in the back. And then it says 8 less than the number itself. It wants you to understand that this is the same number, so it's the same unknown number. So we need to use the same variable that we used before. I chose to use x, so I'm going to continue to use x. All right, and that's the answer for that one. It now is an equation with variables on two sides. Okay, let's move on to number 14. Number 14 says the product of a number and 3. Okay, so a number, let's do x and 3, but I'm going to put the coefficient in the front, is the same as, means equals, the sum of that number I used an x to represent it, and 6. So 3x equals x plus 6, and that's what that looks like. I want you to try and do number 15 on your own, and let's see how you do. Go ahead and pause the video before you do that. All right, so 15 says, 15, and there's my number 15, decreased by means subtraction. The quotient, when I see that, I know I'm going to have some division in the second part here. So quotient of a number x and 3. So I write that x divided by 3 is means equals, and then the 20 goes by itself on the right-hand side. Great. Let's try number 16 on our own now. Again, pause the video, give it a try, and come back. Okay, and here's my answer for number 16. This was by far the most difficult of them all. It did include 2 turnaround phrases. The first one was subtraction. The second turnaround phrase was addition. All right, and then, oh, I forgot to annotate my numbers up here. There we go. Product of a number and 7 is 7x. 4 less than means minus 4 from that. Is equals. 8 more than means add 8 at the end. That same number, so I'm going to still use the same variable x. Okay, let's move on and start talking about how we're going to translate when we have inequalities. Okay, so first, I want you to try and fill in these inequalities and see if you can remember what they look like. Pause the video and try to fill them in. All right, welcome back. I have actually filled in quite a bit for us, all right? When we're translating with inequalities, it's similar to when we translated with equations. The word is means equal, okay? But with inequalities, when you see the word is, it tells you that this is going to be in the same place that your equal to sign would be. So is less than separates the two sides of your inequality statement that you'll have. Is less than or equal to is the symbol here. And in orange, I wrote 3 other phrases that also represent the same thing. No more than, maximum, and at most all mean less than or equal to. Okay, is greater than, again, that's pointing towards the right. And then is greater than or equal to, that is still to the right and it has that line under it. And the 3 other phrases that mean the same thing is no less than, a minimum of, and at least. Okay? If you look at all these examples down here, I have already underlined where the inequality will be placed after I've translated it. I'd like for you to go through and see if you can just simply place which inequality symbol will go where the teal underline is. So for example, all I need for you to do for number 17 is say, is less than, is that symbol right there, and then move on to number 18. So see if you can do those. Pause the video, obviously, and come back in just a minute. All right, welcome back. I've gone ahead and completed all of my inequality statements. Just I didn't put the letters or variables, and I also haven't put the constant terms in. I just wanted to focus on the inequality itself. Okay, so is less than, I forgot to underline, is greater than or equal to here in number 19. 18 also has the or equal to. 20 is at most. A number is at least 16. If it's at least 16, it means it can be 17, it can be 18, it can be 19, but it can't be less than, so that's why we use that greater than or equal to symbol. Number 21 is kind of a logic thing. If the speed limit on the road is 55 miles per hour, you're allowed to drive 50 miles per hour in that zone without risk of getting a ticket. But if you start going above that 55, that's when you would risk getting a speeding ticket. So a speed limit of 55 indicates that you could go equal to 55 or below. Okay, so that's why we use the less than symbol there. Maximum and minimum. A maximum means max of 25, so you can have 24 people, 23 people, but you cannot go above 25. Okay, minimum is the same thing. You can have 6 people, 7 people, 8 people, but a minimum of 5. All right. Now we're going to do the second part. We're going to go ahead and identify all of our variable terms. So a number, so I'm going to put X. A number in 19 is X. A number in 18, a number, a number, a number. So I'm just using X every single time. This doesn't say a number, but I do need a variable to represent it, okay? And then in number 21, that's going to be the only one where I use a different variable. Sometimes we want to use a variable that represents the situation, especially if it's a real life situation. So I'm using the letter S to represent speed limit. Okay. All right, and now let's fill in our constant terms. So negative 10, 18 is going to be 8 over here. It's going to go on the opposite side because it comes after the inequality phrase. Okay, so go ahead, pause this video, fill these in. You should be matching what I have. If you're not real sure about some of them, feel free to raise your hand and ask Miss Brown. I don't mind to do that. Come help explain it if I can. If you feel like you've got an okay understanding of this, that's awesome. This video is finished. The only thing that I do want to add to it is some people struggle. How do I know that less than faces to the left or more than faces to the right? Okay, so here's what I'm going to say about that. If you picture a number line, so let me switch here to gray, and I'm going to do it under the word examples. Here's a number line. The numbers that face left, see this left arrow, this is where numbers are getting smaller. If you start facing to the right, that's where numbers get greater. Okay, so if you think about this inequality as an arrow, that arrow would point to the left, so the numbers are getting less. If you turn this one into an arrow, it's pointing to the right, so the numbers are getting greater. That might help you remember which way greater than or less than is facing without trying to memorize it. And please do not think of alligators, because this is not what we're doing. We're not comparing numbers. We are translating expressions and inequality statements, okay? So it is different. All right. If you have completed the video and you've completed that whole side of your notes, I want you to go ahead and try the practice assignment that Miss Brown posted for you on Google Classroom. It may be completed as a part of your homework unless you finish it in class.